Okay, we're now looking at word problems, and we're using logarithms to solve word problems. And this is the first time this has probably ever happened. So there are many kinds of problems that can be solved using logarithms. As a basic rule, we use logs whenever we have an exponential equation. So sometimes we've got equations like, I think I wrote before, x squared equals 16. And we're not going to need logs for that. But there are times when there's a word problem that has something like this. Now, what we're doing is that we're going to have a formula. And so this is, for example, a formula. And this formula has a bunch of different things in it. And so it's really important. The main point is how to set up the formula. Because you're going to set it up, and then after that, you're going to have to solve. Now, I said that I would get you to, whenever we're solving exponential equations, we want to know the value of the exponent. Meaning, I'm probably going to ask for one of these, n or t. And, well, t is time, but what is n, right? So those are the types of questions. Or down here, there's another formula. I would probably ask you to solve for r or t, because those are going to require a logarithm. So it says here, A is the final amount. We're dealing with, we're going to do some growth and decay. And money can grow or it can decay. So you can put things in there and you can increase how much money's in there, or your money can start decreasing. So this is a growth or decay section where A is the final amount that you end up with. So you're going to start with P. This is called P naught. And this is just an initial amount. So you can have an initial amount, and then your A is your final amount. Now it says there T is time. That's pretty straightforward. And that R is your rate. So sometimes you grow or you decay at certain rates. Usually something like 2% or 3% or 7% or 12%. It's usually a percentage. So we cannot put a percentage in here. We need to turn it to a decimal, which means we're going to divide by 100. And lastly, the most oddest, if that's even a word, oddest, one of the strangest ones is n, where n is the number of compounds. And so sometimes your interest they'll compound it. They'll collect the interest and they'll put it back into the bank for you. And so if there is compounds like yearly, it compounds once. So it collects your interest at the end of the year and throws it back in. But sometimes you can collect it monthly. And so the number of compounds in a month would be 12. And so n would be your number of compounds in I think I might have said a month, but in a year, if it's monthly, it's 12. If you're going weekly, okay, there are 52 compounds in a year. So n is going to be the number of compounds. Now, sometimes it compounds continuously. And so that is where this formula comes in, and it uses the letter E for continuous growth. Okay, so we're going to do 4 questions here, and in those 4 questions, we're going to use the same number of I guess interest rate, 2%, and we're going to use decay rate, 2%, and we're going to So remember that the rate is always, so if you have a growth rate, you are going to have 1.02. where you have the initial amount, 100% of what you had, and then you have an extra 2%. Now, if you're decaying by 2%, well, that means you've got 0.98. You have less than 100. You've got 2 less than 100. So just keep that in mind. Now, example number 1, it says calculate the time it would take to invest $1,000 at 7.2%, and the number of time it would take for it to double. And we have 4 different questions we're going to do here. So it is nice to usually write down some information. So, for instance, what's your final amount? What is it? A? Do we know? If we don't know, we just put a question mark. So it doesn't say what our final amount is. And, well, it doesn't actually explicitly say, but it does say in that it wants us to double it. And if we started with 1,000, that means doubled would have been 2,000. Now, P naught is your initial amount. That would be 1,000. R is your rate. Now your rate is 7.2%. Now we're not going to go 1.0 like you would think it would be 1.07 for 100 plus a 7%, but the formula actually has the 1 built in, so we don't need that. So 7% would be 0.07, that's 7%, but it's 72, so 0.72%. Sorry, 72%, but 0.72 is our decimal. And our n is the number of compounds. Well, that depends, because we're doing 4 different questions for how many compounds we have. And then t is the last one, time. Well, that's what we want. We want to find this. That's what we're looking for. Now, t is in the exponent, so we're going to have to use logarithms. So this is pretty easy to set up. However, we are going to most likely need a calculator for all of these. So yeah, we'll just try it. I have yet to find a way to do this without a calculator. So let's start by first writing down the formula. And you can do this 1 plus r over n to the power of n times t. You can write this formula 4 times here. All right, so I got these 4 formulas. They're all the same. Oh, they're not actually. Annually, monthly, weekly, continuous. I had to make the continuous formula because it's compounded continuously. So we use the E notation there. So we need to do this. We've got the information above, but the n we don't know. So that we'll do here. I'll just zoom in. The n, if it's done annually, the number of compounds in a year is just 1. So we're only going to compound once. So when it comes to this, we can just plug everything in. So A is 2,000. This is 1,000. 1 plus our rate is 0.072 over 1. And then we have 1 times t. Now with this, we can have 2,000 equals, usually we need a calculator for this, but this is just a 0.072 and this is a 1, so we can just add them. There's nothing we need to do there. 1 times t is just t. So now you have to solve this, and this is where logarithms comes in, because we need to isolate the t, which means we need to isolate this, which means we need to get rid of this 1,000. That's our first step. So we're going to divide, because it's timesing, we're going to divide by 1,000, and this is 2, which should make sense because we've doubled it, so twice as much. 1.072 times, or to the power of t. Now at this point we want to get the t down so we can take the log of both sides. It looks strange, but you theoretically could use 1.072 as your log base. It looks kind of odd to write those decimals down there. It comes in a little bit handier though, because it's usually one less step. But we'll just do a basic log, because there is no log that works nicely for 2 and 1.072. So we can bring this t down and turn it to a multiply. So we have log of 2 equals t 1.072. I don't know what happened to the log, so I'm going to write that down. Log of 1.072. And with that, now I can divide both sides by log of 1.072, log of 1.072, and so that's what t is. T is this, log 2 over 1.072, but if you put it into your calculator, you're going to get 9.97 approximately. So it depends on what I want. The answer could just be that, though that wouldn't really be helpful for understanding the length of time it would take to double, where this makes more sense to me. If you tell me it takes log 2 over log of 1.072 years, that makes no sense. And just remember, when you put in your calculator, you can just do log of 2, close the bracket, divided by log of 1.072. 9.97. Perfect. So I'm going to not do the next 2. I'm going to pull up the answer key for it, and I'll just kind of walk through it for the next 2 because they're almost identical, just a little bit different. All right, so let's take a look here. I've just imported the answer key for monthly, and just to show it, because it's virtually the same, but you will be required to have a calculator for something like this, unless you happen to know what 0.072 divided by 12 is. Now, 72 divided by 12 is 6, I guess, so you can say that's 0.06. So, I mean, it is kind of possible, but otherwise you might need a calculator for that. So, 2,000 goes in there, 1,000 is your initial amount. The only thing it changes is the number of compounds. So you can see I wrote that as 12, and I wrote that as 12. Now this, using a calculator, this inside here is 1.06. Sorry, 1.006. So keep that in mind. Step number 1, you just divide over the 1,000 and you get 2 like we did. The inside, like I said, is 1.006. Then you need to take a logarithm of both sides. There's no nice number, so we'll just do log base 10, which I've done here. Now this 12t, that can come on down in front, which it did. And now, instead of like we did over here, where we just the t was just alone, you divide it over the log of 1.072. Here you'll divide over the log 1.006, and you'll also divide over the 12 at the same time. And so when you do that, you get this number. And this is kind of your exact answer. But again, that's somewhat meaningless unless you put it into a calculator. Now, when you put it into a calculator, you want to be very careful that you put it in correctly. So you would go log of 2, bracket, and you want to start with a bracket, and then you can go 12 log of 1.006, and then you can, close a couple brackets, and you can get 9.65. So if you've compounded more times, you can see 9.66. It is definitely faster. I mean, not too much, but it is faster because we've collected more interest and put that into our bank account. Now, if you're done weekly, this thing is done identical again, other than 52 and 52. Those are the only changes that have happened. So first step, you bring over the 1,000, becomes a 2. This inside boils down to 1.001384. It's a lot there, which is why I used a calculator for that, to the power of 52t. Now there's no log that's going to work for both of these. Just like the other ones. So I'm going to do log base 10. Just log both sides, and I can take the 52t and I can bring that down in front. Now the t is by itself, so I can divide this log over to the other side, and at the same time I can divide the 52 over to the other side. And if you do that, you're going to get 9.634. So it is a little bit faster still, which is nice compared to this. Now for the last one, I don't mind doing that one. So we're going to do the same thing. We're going to do 2,000, and we're going to do 1,000, and we have e to the 0.072t. That's our rate. Now, like we've done, I think this is the 4th time, the very first thing you do is you're going to divide over that 1,000, and you're going to get that 2, because it's twice as much. By the way, if I said I wanted you to triple your money, well, then this wouldn't have been 2,000, this would have been 3,000. If I said quadruple your money, then this would have been a 4,000, which would have got you a 4 when you divided this. So just keep that in mind. It doesn't have to be double. Now, you can choose a logarithm to do both of these, and you could just do log base 10, but because there's an e here, I'm actually going to do the natural log, just because. And most people actually use the natural log later on in university. But for now, we just stick to the log, just base 10, except for this one. I kind of like this to be the natural log. So same thing happens. This comes on down in front. Notice there's no number of compounds needed. Don't need to do that. 0.072t because it's done continuously. So that comes down in front, turn to multiply, and then you're left with the ln of e. Now ln of e is just 1. Remember that's log base e of e, and anytime you have a and a, that just becomes 1. So what we need to do is divide 0.072 divided by 0.072. So that is gone. And so I get t is equal to ln of 2, 0.072. None of this needs a calculator. This stuff is a little bit easier. However, I still have absolutely no idea what this is realistically. So you can put on your calculator. You can go ln of 2 divided by 0.072. 9.62, which I think I wrote already in my answer key here. Yeah, 9.627. So definitely the fastest, but not that much better than compounding weekly. You would hardly notice that. So instead of 9.6 years, it's 9.6 years. So it's still 9.6 years, just a little bit faster. Okay, so that's the end of this video. I know it's longer because there's 4 questions we didn't hear, and even that I just kind of looked at 2 of them and kind of walked through them. But we will now do another question. We'll do maybe another 2 or 3 of them in the next video.